Alright, I'm going to teach you two really important identities now. Now we're going to use both of these identities in the next video where we're going to prove a really important result in trigonometry. Before we need to do that, we need to know these two. Okay. Basically, you can find expressions for these guys. Now remember, we're working in radians now. Now that I've discussed it in a previous video, we're going to switch everything from degrees to radians. So really, this is 90 degrees I'm adding on here. Now, these two identities are really useful. So you can find expressions for sine of x plus 90 degrees or x plus pi over 2. In order to know what this is, the best way to think about this is through C1, you could say graph transformations, right? So that's from the old spec. But basically, you want to get your graph transformation hats on here and think about sine of x for a second. All right, remember it's going to look a bit like this. Okay, now this is pi over 2. This is pi. And so what happens when I add pi over 2 to that? I'm basically shifting the entire graph to the left by pi over 2, right? So the entire thing will look a bit like this now, right? Everything will just get shifted down. But what is this graph? Well, this is just cos of x. Okay, so you can see geometrically and by graph transformations that sine of x plus pi over 2, that's just cos of x, which is really cool. Now I want you to do a similar thing by yourself with cos of x. Okay, draw the graph of cos of x and shift it 90 degrees or pi over 2 radians to the left. And what you'll find is that this is negative sine of x. Okay, so these two identities are like incredibly useful. In fact, because they're identities, let me just do the equivalent sign. Okay, so keep those in mind and just why they're true. Play around with that for a bit. But in the next video, I'm going to use both of these to show you some really cool results.